Welcome to yet another session on probability. In today's session, we will understand about expectation. Expectation is a very important phenomenon in business statistics as well as probability because expectation gives your returns over a period of time. Because most of the businesses, or we talk about sustaining over a period of time. So we talk about what is the long-term returns, and expectation really helps us in doing it. Now let us understand expectation by way of certain examples here. Now, expectation is the price money or the entity which is going to give the benefit multiplied by the probability of that event occurring. Now let us take an example in horse race. Okay, when you gamble in horse race, horse one has got a probability of winning 90% or 0.9, and another horse is with a 0.6 as a probability. Obviously, if you bet on this horse, you are most likely to win. But what you really need to understand is that what is the net return I am going to get? Because it is a very favorable horse and most of the time it's going to win. Most of the people will bet and hence the money gets divided, and let us say you get 1000 rupees as the prize money. Right? On the contrary, horse 2 has got lower probability of winning compared to this horse, but let us say the prize money is 10,000. Now, when you arrive at the expected value by this formula, or the expected value is basically the entity multiplied by the probability, or in this case it's the money value multiplied by the probability, or expected monetary value in this case will be 900 and here it will be 6,000. So obviously you can understand by taking more risk, the chances of getting higher returns in horse 2 is better compared to horse 1. So that's why I said that probability alone is not a matter of concern. Probability associated with the entity or the money value, and that makes a difference. So most of the business scenarios we will be dealing with money values or opportunity gain or opportunity loss. So we arrive at expected value based on probability and the monetary value over a period of long time. Let us explore expectation. Expectation definition: expected value in probability, weighted average of each possible value of random variable and the probability of occurrence as a weight. So mathematically, E of x is equal to sigma x into probability of x. Now the prize money is 1000, and if you get heads when you toss a coin. I have conducted several trials of tossing the coin and the results are here. So as per the definition, the expected monetary value or EMV is given by 0.5 into 1000, that is 500. So in the first experiment of 10 trials, I have got 1, 2, 3 times hit. So every time when you get heads, you get 1000 rupees. So 3000 by total number of trials gives you 300. Now I tried the same experiment with 20 trials, and this is the result. You can see the heads. Whenever I get heads, I get 1000 rupees. So out of the total 20 trials, on 12 trials I got heads. So 12,000 over 20 is 600. Now what you can observe here is that you really see that the value of 300 has moved from 300 to 600. That means as you keep increasing the number of trials, the expected value will approach close to 500. We will now see by way of a couple of examples how expectation can be applied in a business scenario. Most of the business scenarios will have multiple events, joint events or conditional events. Now this is a typical example. A businessman has to travel to Mumbai to participate in a business deal. And I would suggest kindly go through this example slowly, and if you want, you pause this slide for a few seconds. Once you are completely read, then we can take it further. So 3 options: either you can take shuttle, or you can park himself on the previous night at a hotel at Bombay, or by way of taking a taxi to the airport. Now the possibilities are catching the flight or missing the flight. If it takes the airport shuttle, his cost of reaching the place is 10,000 minus 50, and that is his monetary gain, and the probability of success is 0.94. Therefore his expected value is multiplication of this, and this will give you this. And if he misses the flight, and this is what happens, minus 50, and the probability of missing the flight is 0.06, and hence. Similarly, you can analyze for hotel stay and taxi. In hotel stay, you spend 1,000 rupees for the hotel stay. The probability of reaching the place is 0.99, so that becomes 8910, and you get the net expected value is this. He takes a taxi with a probability of 0.98. His expected value is 9310, and if he misses it, he will lose this much. So in all the three scenarios, the expected value is 9350, 8900 and 9300. So obviously by taking the shuttle is the best possible option for him. Please read the problem fully. You can just pause on the video for some time and read it fully before we proceed further. Now let us understand the shop owner's expectation on his course of action. Now this is the course of action table, and this is the payoff table. Now in course of action, if he stocks 20 and if the demand is 20, he gets a marginal profit. Similarly, if he stocks 30 and if the demand is 30, he gets a marginal profit. Now in case he stocks more and the demand is less, this rule apply, and you will find that his net is 0. You can apply the values there for demand and stocked, then you will get it 0. Again, if his stock is less and if the demand is more, then he end up opportunity loss, and that is what is profit after conditional opportunity loss, and this is what is this. Okay, you can apply it in this equation and you will get this value. And this is the way you build the table. Once you build the table, these are all without probability, or what one can expect, assuming that if you are able to do that. But in reality, there is a probability of these demands, and that's how you arrive at the payoff table with an expected value. The expected value is 0.35 into 200 will give you 70. Similarly, every cell you can fill it up and you arrive at this payoff table. Once you arrive at the payoff table, you just add it up under 20 loaves if you stock, 30 loaf if you stock, and 40 loaf if you stock, you get the expected monetary value, and that is 160, 180 and 80. Of all the things, you find that stocking 30 gives a maximum expected value, and the shop owner should go and place order for 30, or in the long run he is bound to get an expected amount of 180 as the payoff. To summarize, most of the business situations and scenarios are sustained over a period of time. So it's better that we use expectation, because in expectation you arrive at the expected returns over a period of time, and that is a better measure instead of just going by probability. Now a word about gambling. No matter whether it is horse race or card game or casinos, everyone loses in gambling. And that's the way they make money. Nobody wins in gambling because there is always a loss associated with that. One may get a fortune in few trials, one makes good money. But what happens is that gambling sucks people and you keep playing it once again and you start losing money. Wisdom should prevail at the right point of time to withdraw from gambling so that you are benefited. But that is normally rare. So my advice would be, please don't gamble. You will only lose in the long run. Thank you.